Honors Algebra 2, 2-1 and 2-2 functions and slope. We'll see how fast we can get through this. A lot of it should be review. Most of it's terminology you got to recall, like function, domain, range, and then rate of change. So a function is a relationship between two quantities where every input has exactly one output. And some of the terminology or words we use with that. We have the x values, input, and domain. They're all describing the same thing, and so those are kind of interchangeable. So the x values, the input, and the domain. The results are the y values, output, and range. So they kind of get matched up there. So a lot of you know x and y, input, output, then the domain and range are also describing a function where every input has exactly one output. Three ways to represent a function: a table, a graph, and an equation. You should be able to do that all three ways for a function. So an example of that, a hot air balloon starts at 250 feet and it's increasing at 20 feet per minute for 5 minutes. And so we can describe that within a table as the minutes change, what happens to height, and we can do it in an equation. So we have 20t, so however every minute it goes up 20 feet, and then adding to the starting values is height, and then we can show that within a graph as it changes. So 3 ways to show a function. We should be able to describe visually or if something is a function or not through a table. And when we're doing that, we're looking at all the inputs. Does every single input, does each of these inputs go to one output? So they all have to be used, and then they all have to go to one number. So does 1 go to one number? Yes. Does 2 go to one number? Yes. Does 3 go to one number? Does 4 go to one number? Yes. So then this would be yes, it is a function. So here, does 1 go to one number? Yes. And we can draw a line sometimes. Does 2 go to one number? 2 goes to 4 here, so that sounds good. And 2 goes to 4 here. Now because 2 goes to the same number, that's okay. It's a repeat point, but the number 2 is only going to one output, 4, and then 3 goes to 6. So yes, that's still a function. Here, does 1 go to one number? Yes, it goes to 2. 2 goes to 7. 2 goes to 1. So now really the number 2 is going to two different numbers. The number 2 goes to both 7 and 1. So then no, it's not a function. So examples, we see it in life. They're not really talked about as functions, but they are used. So a cookie to a person. If the cookie is the input, and then the output is the person it goes to, and does that one cookie go to one person, it's a function. If that cookie goes to more than one person, so if someone shares that cookie, then it's no longer a function. So is a phone number to a house. The phone number I have for my house goes to one house. So if I had a phone number and went to multiple houses, that really won't make a whole lot of sense. But so a phone number goes to house is a function. Vehicle to license plate. So I have a vehicle number. Does that go to one license plate? And that would be yes. And some of these you did in reverse. So if like we could do the house. Does the house have one phone number? That would not be that would not be a function. So just because it this direction, input, phone, output, house is a function, doesn't mean the reverse is true. That's the if and only if statement from geometry is not true for this. Name to phone number. So like my name actually has multiple phone numbers, my cell phone, work phone, house phone, and so it's not a function. Some examples in life. So for these, you can just look at these real quick and tell me if they're a function or not. So I'll pause it for the time and then hit play. This one goes to two numbers, so no, it's not a function. For here, these all go to one number. It's okay. 7 goes to a -6, 8 goes to -6. They're each going to one number, so that's okay. That's a yes, it is a function. So a vertical line test is just testing to see if you draw a vertical line, it's saying at this x value, so at this x value 3, how many y values does it hit? It only hits one y value. So every vertical line you could draw, any vertical line you could draw, can only hit 1 point. So if you could ever draw a vertical line that hits 2 points, it's not a function. So here I don't hit any points. here I could say I can hit like 1 point if it's at the vertex over here, but here I hit 2 points. So since this one line hits 2 points, it's not a function. Here, this is a function. Every vertical line hits 1 point, and this one obviously is not a function because I hit more than 1 point. So a function notation, we have f of x. F of x is the notation for a function, and it's the value of f at x, or f of x. And that's usually how we say that. It does not mean f times x. So when you see this, it's just telling you, one, it's a function, and it lets you know what the x value is. And actually, let me go back. Let me add one more word back here to here. We have input, output. We should also add independent, and dependent. Because our y values are dependent on the x values. And so that's another word to describe input, output, x, y's, independent and dependent. And that helps a lot with word problems when you're trying to figure out what axes they go on. So the independent is always the x, the dependent is the y, so which one depends upon the other. So the graph of f of x is set up for all points x, comma, f of x. So you can think of that as y. That's what a lot of you think of it as. You should. But we can use f of x to note that. So here, if we're going to evaluate this for x equals -1, 0, and 1, all we're doing is we're making a table. We're making an input-output table. So if x was -1, 0, and 1. And we're just going to plug them in for x in this equation and solve for y, which is the same thing as f of x. And so just plug and chug, we say. So if I put -1 in there, 3 times -1 is -3. -3 minus 2 is -5. If I fill out the table, I get these values. I could plot these points and connect them to show a graph for that. So then we have the equation and table and graph. Using a table, we should build a graph. Now you probably recall some shortcuts, but I want you to be able to graph making points, because that'll help you with the more difficult equations or different functions. So when I'm looking at this equation, I right away see I'm going to multiply here x, our inputs, by 1/2. So right away I know the numbers I'm going to choose are going to actually be multiples of 2, positives and negatives. That way when I multiply here, it actually keeps it whole. So that's having a thought process, a forethought about the problem. So when I multiply 1/2 times -2, I get -1. Plus 3 is 2. So I'm trying to think of numbers that actually help me do the mental math. So here will be 3, and then here is going to be 4. And I can see a pattern that's involved here. That pattern will continue on for these functions. So -2, 2, 0, 3, and then 2, 4. Then I can connect them. I can draw with my tablet, and I can't. Give it one more shot. That is horrible. Let's see if I can use get some help here. Yep, technology is great. Okay. So rates of change. Last thing, rates of change just describe how two quantities or points are changed. So any 2 points, how are they changing from one point to the other? That's rate of change. The vertical change divided by the horizontal change is how we find the rate of change. So a formula for rate of change here is the y2 minus y1 over x2 minus x1. And that's given these 2 points where you have x1, y1, x2, y2. And the 1s and the 2s are just stating how they're different points. So that's just notation for that. So slope is a constant rate of change. So slope is a very specific kind of rate of change. So a slope is a kind of rate of change. A rate of change is not a kind of slope. So slope is the rate of change of a line. So we know when we say slope, it has to be a line. So again, slope, we can use the letter M to note that. We should also recall rise over run. Rise is the y values. Run is the x values. The formula y2 over y1 divided by x2 over x1. Or some notation. The triangle here, this just means change. So we may say change in y over change in x, and this is the notation we go by. So we want to find the slope between here. The first thing we want to do is make sure we see the y values, and it does not matter which one you start with. So if I want to start with the 4, it'd be 4 minus negative 3, and then I would divide by the x's, so it'd be 2 minus 6. And the important thing is, if I'm starting with this point, I have to have it here and here, the first value on the numerator and denominator. So I evaluate that, I'm getting 7 over negative 4. And it doesn't matter if I write that negative 7 force, 7 over negative 4, or negative out in front. They're all the same thing. And let me show you that problem again, but let me do it with the other point first. So if I want to do the other y value first, negative 3 minus 4 over 6 minus 2. Notice how negative 3 first, so I had to put the 6 first. So I evaluate that, I'm having a negative 7 over 4, and that's the same value. So parallel lines, last thing here, parallel lines, lines that do not intersect, those would probably intersect down the road, but have equal slopes. They are the exact same value. Their slopes are the same value. Perpendicular, and the symbol for perpendicular is an upside down T, and they're just two lines, any two lines that form right angles, 90-degree angle right here, and they have opposite slopes, so one is positive, one is negative, opposite, but they're more than that, they're opposite reciprocals, reciprocal slopes. They have to be both opposite and reciprocal slopes when they are perpendicular. So if I have a slope as 2/3, a perpendicular slope is going to be negative 3/2. So opposite sign and then flip it. And if you think about that, one of these lines is going downward. That's always in the case downward. Then the other line is going to be going upward. So that's why one's positive, one's negative. And I can't draw lines. So opposite reciprocal will be perpendicular lines. So there we go, functions, slope. Make sure you know what a function is, domain, range. You can show that with a table, a graph, and then table, graph, an equation, and then you graph basic equations by plugging and chugging, and be able to find rates of change or slope. Have a good night. See you tomorrow.